Enokidani with his presentation analysis of factors affecting milking claw vacuum levels using a simulated milking device.
Hello everyone, welcome to Sapporo, Japan, and enjoy to eat Japanese dairy products, especially sweet cake. So my presentation title is Analysis of Factors Affecting Milking Claw Vacuum Level Using a Simulated Milking Device. Background, NMC, National Mastitis Council recommended to evaluate milking system performance with 4 steps. Step 1, observation test with machine learning and not learning. Step 2, dry test with machine learning but not milking. Main test factor is airflow in milk line and vacuum lines. Step 3, wet test with machine milking. Main test factor is airflow, milk flow, and milking technique. Step 4, flow simulator test for evaluating milking system performance and optimizing operating vacuum. Milking system technician must know basic factor of milking system. We will show the evidence of basic factor for observation test. What is the matter in this picture? I will clarify the important factors of milking system from now on. Material and method. We used flow simulator like this picture and milked with using bucket with flow meter and 4 simulated teeth. Flow simulator, simulated milking, vacuum measurement devices. We adjust at 30 seconds after starting simulated milking. Mean claw vacuum was measured at 2 minutes after wait this 30 seconds until stabilize the flow. Analyze factor and water flow rates. Water flow rates have 5 steps, 1.9 kilogram to 8.7 kilogram per minute. Analyze factors are operating vacuum, high line system, low line system, high line system with ATO, automatic takeoff, milk tube length, milk tube diameter and aperture diameter, tubing configuration, vertical tubing, level tubing, milk tube lift height, claw type, and milk sampler setup. This slide shows basic factor of analysis and flow rates. Oh, sorry, mistake. Yeah. This slide shows factors of operating vacuum. Red line is on high line system curve, and black line is on high line curve with ATO. Both high line system claw vacuum starts at 50 kilopascal and go down around flow rate quickly in by lift vacuum loss. High line operating vacuum depend on lift vacuum loss. With ATO, high line system go down more than red line curve. Yellow line and blue line curve are on low line system. Claw vacuum do not go down with lift vacuum loss. Yellow line curve has with 60 millimeter diameter milk tube. Blue line curve has with 22 millimeter diameter milk tube. Then low line operating vacuum is lower than high line vacuum. Purple line curve is dual vacuum milking system on high line, named superline system made by Orion Company in Japan. Milk line vacuum is 60 kilopascal, higher than common high-line vacuum. Then vacuum lift loss is smaller than common high-line system. Put on NMC recommended flow vacuum range on this graph. On high-line system, low flow rate area means over milking times. And high flow rates area mean poor heat and massage time. We have to get operating vacuum in NMC recommended flow vacuum range on every milking system as possible. We have to use deciding operating vacuum with using flow simulator at installers and travel times. On this picture, roll line system and dual vacuum system operating vacuum are too high vacuum. This is operating vacuum at 42. This slide shows the factor of milk tube length on high and low line system. On high line system, milk tube lengths have 248, 288, 328, and 317 centimeters with ATO. The longer milk tube make low flow vacuum more over with ATO. On low line system, tube length has 200, 250, 300 centimeters. The longer milk tube make low flow vacuum similar. Upper side picture shows two long milk tube lift, long milk tube, and aperture diameter. Lower side picture shows two short milk tube and poor flow alignment. Short milk tube length better than longer, but two short milk tube sometimes makes poor flow alignment like this picture. This slide shows the factor of milk tube diameter and narrow point on high and low line system. On high line system, milk tube diameter has 40, 60, 60 with milk checker. Small difference on aperture diameter occurred, big difference on high line system vacuum like a bottleneck. On low line system, milk tube diameter has 14, 16, 18, 22 millimeter. Smaller diameter make low flow vacuum clearly. Upper side picture shows mastitis checker. Lower side picture shows all type of vacuum cutting devices with narrow point. This slide shows factor of milk tube on low line system, of milk tubing on low line system. Level tubing is lower than vertical tubing. Upper side picture on vertical tubing shows that milk flow from up to down. Lower side picture on level tubing shows that milk flow from left side to right side. This slide shows factor of milk tube lift height on low line system with same milk tube diameter and length. Milk tube lift heights have from 0 to 80 centimeters. Higher lift heights makes low flow vacuum. These pictures show milk tube lift height test on dairy farm. Upper side is 40, lower side is 16. This slide shows factors of flow type and sampler setup. Black line curve is top flow with sampler, and blue line curve is top flow without sampler. Difference between black and blue curve is sampler setup on top flow. Red line curve is bottom flow with sampler, and green line curve is bottom flow with a sampler. Difference between red and green curve is sampler setup on bottom flow. Difference between black and red is claw type with sampler setup. And difference between blue and gray is claw type with a sampler set. Bottom type claw vacuum is higher than top flow type in spite of sampler setup. Bottom type claw vacuum is better than top flow vacuum on low line system. Conclusion. Combination of flow simulator and vacuum measurement device could analyze the factor affecting the milk flow vacuum level by changing flow rates. This method can apply for diagnose the performance of the milking system. Milk tube length should be as short as possible with optimal claw alignment. Milk tube diameter should be over 16 mm, especially over 18 mm for low line system. Milk flow should not conflict with gravity. Bottom flow claw is better than top flow claw. Constricted parts like a mastitis checker, milk meter, vacuum cutting device should be carefully installed. Do you see any itch on this picture? A narrow point cutting device with narrow point, milk tube lift, and narrow outlet milk tube. Thank you very much for your kind attention.